good evening, afternoon. It's nighttime when I'm doing this, so good afternoon. I guess it's fourth period with you all. Welcome to Unit 2. We just finished up Chapter 1, we took our test, now we're moving on. If you notice, this is actually Section 2.0, so it's not the beginning of Unit 2 for the algebra. We're doing a little bit of extra work. We'll talk about that in a moment, but I want you to put down inverse operations and combine like terms in your table of contents. Today is 10:25. Again, I'm not with you all because I'm with my son Finley. And actually Weston got sick too, and I'm starting to get sick too. So this is awesome timing. The goal here, just to give you some lessons. You'll watch this video, answer a couple questions throughout the video. Then you'll do a worksheet and hopefully you will be done. You should have just finished up your quick write on our quote. Think about the quote. It should remind you of how to behave during days like this, right? If you have integrity, if you know what to do, you shouldn't need rules. So just behave yourselves. I appreciate you all. I can't wait to be back next week. So let's get started. So this should be in your notes. This is a new unit, but first we're going to cover some prerequisites. Prerequisites are things that you need to know before you move on, and these are things that I think you should know. So we're going to cover them because it's a new unit and we got extra time and we're going to enjoy ourselves. So the first thing we're going to talk about today is operations and inverse operations, things that you need to know as we move into our chapter on solving equations and inequalities, and also combining like terms. So, as you can notice down here in the page, you're probably going to need half a page to a full page of space in your notebooks. I'm just a little bit distracted because I got to plug in my iPad before it runs out of battery. You'll need a half a page to a full page for each one of these two things. So hopefully you're doing that. Operations and inverse operations is one thing, combining like terms is another. And like I said, at the end of class, you'll just work on a worksheet. All right, so operations. This becomes just review, okay? We should know the operations. The basic operations are add, subtract, multiply, and divide. We've talked about a few, but these are the main ones. Okay, so you have something like 2 plus 2, 3 minus 2, 4 times 5, or 6 divided by 2. Or it could also look 6 divided by 2. It's important to understand that those two kind of look like that. Okay, I'm going to make my little pen a little bit smaller because it's too intense. So those are the four main operations, and we've talked about you have to do them in a certain order. We've talked about PEMDAS, which is parentheses, exponents. Then you get into multiplication and division. They're a team. You do them from left to right, and addition and subtraction. Now, again, those go from left to right. This is review. I don't know if you need to write this in your notes. I'm just going over it. These are our operations. There's a few fun facts about these operations, but at the end of the day, you just need to know what they are. This operation gets substituted out for a little dot. This could be 4 times 5. Another way that you could write this is 4 groups of 5, which we've talked about in the past. These all mean the same thing. So maybe putting this in your notes is going to be helpful to guide you. We'll mostly write it like this, but with positive and negative numbers, this really helps. But they all mean the same thing. 4 times 5. Write 5 4 times. 4 groups of 5. 4 groups of 5. Okay? You need to be able to recognize it. It's going to be really important for this chapter. Plus and minus, you should know from like forever ago. So yeah, there you go. That's operations reviewed. Now, what we want to start talking about, what's really important is, what's an inverse operation? So an inverse operation, I'm going to write a definition. Inverse operations undo original operations. Think about your computer. It's that little undo, the little arrow button that like go back, right? You don't want to do that. Undoes operations. Okay, so I'm going to give you a second to write that into your notes, and then I'll kind of explain myself here in a little bit. I do understand that my handwriting can be a little ugly, so I'm going to go ahead and type it in here. Oops, that's white font, does not help. Inverse operations undo original operations. There you go. Okay, what I mean by that, if I have 4 plus 7, right, the original operation is right here. Add. If I want to undo the add, what would we do? To undo a plus, we have to do the opposite. So what we would do is minus 7. And that would bring us back to our original number. We had add 7, and then we did minus 7. Oops, that's not minus, that's mines. Minus 7. And you get back to original number. You undid the add with the minus. So that makes plus and minus are inverse operations, meaning they undo each other. So again, give you a second to write that in. Plus and minus are inverse operations. They undo each other. Again, if my pauses aren't long enough, just pause the video for a second and write it down. There's no time limit on how long you need to watch this video. Okay, so if plus and minus are inverse operations, let's see if the same thing would work. Let's say we have 5 minus 3. 5 minus 3, we should know is 2. So the original operation is minus. To undo a minus, if I want to take away the minus 3, the inverse says if plus and minus are opposites or inverse operations, if they undo each other, to undo a minus, I should have to do a plus. And I'm going to do a plus 3 to get rid of the minus 3, which then again would bring me to my original number, which is 5. Because plus undoes minus. Okay, so there's an example of inverse operations with plus and minus. Get this into your notes, by the way. Sweet. All right, so let's take a look at the other operations. We have two operations we haven't talked about, so let's do this. I'm going to erase this whole board. Nope, that wasn't my eraser. Why is it erasing? Oh, that's, huh? Oh, there we go. I don't know what just happened. Can I erase words? I can't erase words. I want to erase the whole thing. Sorry, this will take a second. All right. So if we're going to talk about plus and minus, the other two operations, if you haven't figured it out, are multiply and divide. So if we have something like 4 times 5, that means we're going to do 4 groups of 5. Or 5 groups of 4, it's the same thing. To undo a times, right, which is multiply. Multiply means make more groups or groups. To undo that, we would do divide by 5. Now that can look 2 ways, right? We can write divide by 5. And then 4 times 5 divided by 5 would bring us back to our original number of 4. They undid each other. Another way to see this, if we had 4 times 5, right? So that's multiply. And then we did the divide line, right? That line means divide. 5. Well, then we've just created a giant 1. And we've gotten rid of our 5. And again, that would equal 4. Because multiply and divide are inverse operations. Okay, so get those examples written down and get that phrase written down in your notes. All right, so let's take a look. Does that apply then if we do it the other way? And what are a couple ways that this could look like in our notes or problems? All right, so let's say we start with something that we should know. 8 divided by 2. We should know that 8 divided by 2 is 4. But we want to get back to our original. So to do the opposite of divide, we should then have to what? Multiply. Multiply here times 2 would give us back to our original answer because 8, let's see, 8 divided by 2 is 4 times 2 is 8. They undid each other with divide and multiply. Now, another way that this would look, let's set up like a fraction. If we have 8 divided by 2, again, this is what divide can look like. And you multiplied this by 2, which again, we need to get into the habit of understanding this could be 2 over 1. Well, then you have another giant 1 right here, and you end up with 8 over 1, which just equals 8. We got our original number, and we got left with our original number. The multiply and the divide canceled each other out. They undid each other, which is the word we're choosing to use today. So again, we can see that multiply and divide are inverse operations. Again, get this in your notes. I'll give you 30 seconds. couple things to note. You can pull this slideshow up. It's in the Google Classroom, so feel free to have this in front of you or split your screen up or whatever helps you do it. The sub could have them up on the screen if that'd be helpful. You can go through these and take some notes. But we're doing all this pre-work because we're moving into solving equations. And basically, to solve an equation, you have to undo a bunch of operations. And how do we undo operations? We do the inverse. We do the opposite. And that is our technical term for today, which is inverse operations. So, in order to do that effectively, we got to make sure that we're in a simplified form. So we're going to start talking about terms. Terms and subsequently how to combine like terms. So a term is any value, variable, or combination that has their own exponent and team. I don't know what I didn't really prepare it too well for that phrase. But a term is any value, variable, or combination that has their own exponent and team. So if we have integers, examples would be integers, which you should know are positive and negative whole numbers. So like 3, -5, 17, right? Those would be an example of a term. That is a term, that is a term, that is a term. A lot of times we put the negatives in parentheses so you know. A combo would be something like 3x, 4y, 16f. That puts it into its own field because 3x cannot be, is different from 4y, which is different from 16f. This is all review. Variables, with different exponents. So like x and x to the third, those are different terms. Those are unique terms. Because x is talking about any number, and x to the third is talking about any number times itself 3 times, which is just unique. Which would then make something like 3x different from 3x squareds, or cubes, I should say. So these are all different terms. They're mostly separated by variables and exponents. Those are the keys right there, right? So this would be, over here, this would be groups without exponents. Those are all the same. Those are going to be combined. This is numbers and different variables, which makes them different. And then we distinguish them also by the little number up there. Another example would mean x squared is different because it's only a different number multiplied by itself twice. I apologize, this isn't as thorough as it could be. But I guess the point across. A variable is, a term is any value or variable or combination that has their own exponent and team or grouping. I'll say that. I'll write that down too. Probably should look up what it actually means. But I didn't. I don't have my phone by me. So I'll get you a better definition. Leave some space for a better definition. So go ahead and write this information down, and then we're going to talk about what's important about knowing all of these, which is how to simplify an expression that has a bunch of different ones of these. so let's go ahead and review kind of what it means to put these together. So combine like terms is simplifying an expression by grouping terms together that go together. I'll explain what that means in a moment. Simplifying means less complicated. So if you have a bunch of numbers, we just want to make it less number. And how do we do that? By grouping terms together that go together. So if there's a couple of non-variable terms, we want to combine them. So it's just one set of integers. So I'm going to give you just kind of one kind of complicated example and try to dive into what that looks like. So if you just end up having like 3 plus 2x minus 7x squared plus 5 plus negative x minus 4. Okay, at this point you have a bunch of stuff and that's too much. Okay, so we want to start combining things that can go together. And when I first taught this to you in 7th grade or 8th grade, probably 7th grade, we use shapes. So I'm going to go back to that. Okay, so you want to start on the left side. Remember, we always start over here, right? Just because we read left to right, so we start at the left. And we want to identify the first term. Little side note for terms. Each term carries the sign to the left. I'll explain that in just a moment. Each term carries the sign to the left. So that'll make sense in just a moment. So we're going to start here with the 3 right here. So I'm going to use a very basic circle. I use different colors too. So I'm going to circle a 3. Now, that is an integer. It has no variable. It has no exponent. So it's just a number. So I want to find any other numbers in our expression. And if we look here, this is a 2x, so that can't be it. This is an x squared, so that can't be it. And then we run into this 5. So 5 is just an integer, much like 3. So we're going to put them together in team circle. Now, again, this is extra work. You shouldn't have to do all this, but you can. So here we go, 5. And then if we read the rule, each term carries the sign to the left, means I'm going to circle the 5 with the plus to the left, because that's important. That's a plus 5, right? With that, we go down the line. X is a variable. It's not just a number, so those are not the same thing, so we're not going to combine them. And then we get to 4. And 4 is a number, and we carry the sign to the left. So when I'm circling my minus 4, or my 4, I'm going to include the minus. Okay? So then we're going to have team circle over here. We're going to combine things there. And then we're going to add, we're going to pick our new shape, we're going to do this in blue, and we're going to go with squares. So we've got our 3, so the next term we have is this 2x, and it's a plus 2x. So I'm going to take a blue circle, and our square, sorry, and put it around here. Okay? So that is a number and an x. So I'm going to go to the next term, and I got a 7x, but there's a 2 up here. So the 2 means it doesn't go with this x because they are different. So I'm going to keep going, and I got plus negative x. So I'm going to put a big square around that. Okay? And then we're just going to give our last one the dignity of getting a shape, and that leaves us with this negative 7x squared. So first I'm going to leave team rectangle in here, add, and then we're going to use green cloud. So there we go, cloud. Hopefully you don't waste all your time using these tools, drawing shapes and stuff, but it is helpful. If you're having trouble, this does help you. But again, I wouldn't spend all my time doing that. Okay, so inside each little shape, we're going to do all the math that is circled. So I'm going to do 3 plus 5 minus 4. 3 plus 5, that's 8, minus 4 is 4. So what that means is that my circles all add up to 4. I'm going to do the same thing for the rest and hopefully leave some room. So I got, in this square, I got a 2x and a plus negative x. So if I have 2x and, right, and a negative x, I have 2x. Take away one of those x's, I am left with just a giant x. And then negative 7x squared. I'll put that in parentheses. So the simplified version of all of this ends up being 4 plus x plus negative 7x squared. It doesn't look very simple. It's just a simplified version of this. This is simpler than this. That's all we need. Okay, so that's kind of our review for simplifying and combining like terms. What you're going to do next is you're going to get a worksheet that it's in the Google Classroom. Pull that up. Couple questions to answer. Should take you 5 minutes, maybe 10 at the most if you're talking. And that should be it. So thank you for watching. We'll have another video either tomorrow or Wednesday. I'm not sure if videos are always going to be by me or by somebody else. But I do hope you enjoyed, and I'll see you soon.